So the next presentation is by Dr. Nosenko from the Institute of Physics of Metals. You can see the title on the screen. Thank you for this opportunity. I will report to you shortly about the project that we're conducting in the Institute of Physics of Metal and our Department of Crystals. It's hard to talk after diamonds, gold, and silver, because I will talk about simpler things using industrial raw materials and iron. Metal melt and construction. We are developing for more than 10 years, the materials that are nanocrystalline composita that are made up of amorphous matrix that is cooled by quick cooling and structures up to 2 to 13 nanometers and thermal treatment. We have obtained a number of materials and we have several innovations which can be compared to the best international analogies. And a practical example that I will show you at the end of my scientific and theoretical part. It's a picture that shows how the correlation of these two parameters is expressed as the amount of nanocrystals and the size of the nanocrystals. How does that come together in the magnetic characteristics? Is the magnetic permeability and the force. What are the problems that we solve as we are oriented to Ukrainian production industry? It is known that any system, whether it's a measurement devices or sensors, they have magnetic materials. And naturally, magnetic cores can be small, from several grams of weight to 10 grams, and there can be also bigger, more powerful sources which use 2, 3 or more kilograms. And these are the fields that we work for when we create new materials. Of course, these magnetic conductors have to have certain advantages before traditional, and this shows all the potential market segments for these uses. We have a goal to create a more energy effective components. So our goal is to create energy savings, to create miniature components for telecom industry, and as was said before, the computer equipment and the management systems become smaller and smaller, and our goal is also to create a breakthrough in instrument building. The core of the technology is rather simple, but the constant demand for this kind of technology, the quick quenching, and basically two projects that are financed by the Agency on Science and Development, and they are oriented at creating an industrial technology that will give us 90% of high quality output. This is some example that will allow us by the end of this year to create a modules that will produce about 5 tons of product as a magnetic stripe or a band per year. This is going to be a highly competitive product. Our work is oriented at specific applications and creating specific products from this strip about 1 million units per year or more. And we also create the technological line that includes various operations: the cutting, the winding, the thermal, magnetic treatment, encapsulation, and production of ready devices, transformers, trussels, and various converters. This here shows some economic data. It shows that there is an absolute progress in 3 or 4 alloys that we had developed, and we see here advantages if compared to ferrite cores and other materials imported to Ukraine. Besides, our customers have always been interested in absolute records, conductivity, permeability, and low, stable level of core losses, and the redundancy of magnetic stability, magnetic properties. So we see this technology is compared with traditional materials, magnet, ferrite, which constitute the core of Ukrainian industry in this field. It has to be noted that we have developed the technology of cutting the materials, and the magnetic cores of this shape had been already used in the companies created in Ukraine, and which is dealing with electron beam melting of Titan. So 20 of such cores will help to create 1.5 megawatt transformer. And of course, low losses, and it's a transformer of approximately my size. Now, some telecom things. These small cores provide the broadcast of a system of a video and audio. They're also mechanically redundant and resistant, wear resistant, which is the requirement for most of the companies that use such material. Now, a few words about energy savings. Indeed, this is how much electricity is used all over the world, and it's a trend of the time to talk about energy savings. When the general energy consumption is reduced, we are still losing. We're losing 4 to 5 times more energy due to inefficient alloys like steel, but also we lose energy because we cannot properly control the use of energy. Now, some numbers and figures. The Ukraine exports about 1.6 million of ferric alloys. This is basically ore. Maximum price, if the company does it not through offshore, is $450 per ton. If our metallurgy will be able to take all the complexes that we're building, that are built on a very low budgets, financed by Academy of Sciences or sponsors like UNTC, we can sell easily on the market $40,000 per ton for any amorphous alloy, if it has any kind of properties. And 1 ton of amorphous alloy covers all our currency expenditures, 8 tons of ferro alloy. So this is, for instance, the current cooperation of one of our factories with Siemens. The 2 cores, 2.5 kilograms or 4.4 kilograms. Or if we take the telecom Petrovsky factory that produces for telecom and military telecom. We have this equivalent. It's per 1 kilo. And interesting that our partners in application of our materials are such academic institutions as Institute of Electrodynamics. I'm very thankful to our partners, especially who deal with high voltage electronics, and Impulse, power cores, filters of magnetic noise. We have huge success in creating benchmark industrial transformers of current that are used in control grids. These are benchmark transformers, and in this regard we have very active cooperation with the Institute of Electrodynamics and other companies which provide to us their results of their test results. This is a unique thing that we've been doing with the Lviv Center of Aerospace Research. It shows the efficacy of using our nanocrystalline materials in magnetic meters. So this is a magnetometer, provides a much higher precision than a ferroalloy, and is now exported into more than 20 countries of the world. It's a very important component for geology. This again is the industrial grade measurement sensors that measure up to 3000 ampere power. It's a whole system that was developed by Altest company. Sells into more than 50 countries of the world. These are comparators. They are controlled to use the output of all industrial transformers in Russia, in India, Poland, and some other countries. And this is a unique device which was made in the recent 4 years by Institute of Precision Measurements. And standards of measurement of inductivity and impedance, which is due to our transformers. This is a state benchmark of inductivity, also, which is also used with our magnetic parts. Another unique system for the same institute, which was commissioned by the Department of the U.S. This is a Polish and Belarusian and some other countries. Of course, these are not competitors, but these are companies that we coexist with. Another company, an Octagon Corporation, who produce millions of tons of similar materials. We cannot compete in their price. Of course, there's always China, who are subsidized by the state, and in the last 8 years they've created 9 companies financed by the state. They are almost all of them like the company which I will present to you now. They produce from a ton to 100 tons of product, and they compete with these monster companies, and they also ship products to them. So we only can compete in quality, not the price. So we have to work where your mobility is your money in the bank, where you can swiftly respond to the market demand. Nothing else is your market advantage. So this is a breakdown of what we have been looking for 8 years. This is well, earlier we couldn't offer a lot. Now there's 20 years of work behind us. These are some price advantages. And another thing that I have the honor to present to you is a completely new project which is aimed at high mechanical properties of materials, and it's aimed at 3D amorphization. It turns out that the corrosion-resistant ribbon and bulk can help build a very simple molds. So about 17% of iron and micro hardness. This is a way to do coatings, titanium, silicon. So it's a way to higher wear resistance. So these are again another advantage of our materials. These are thermal panels. The low-strength corrosion-resistant materials, quenching, can be used to produce thermal panels. They can be used to heat residential areas. This is a prototype which was done without budget financing by our industrial partners. They can be used to dry grain or other agricultural products. This is a last example. This is the heating that we installed for our conference hall at the Institute of Physics. Now these panels are at the back of everyone's chair. It's totally warm there. And this is a dryer for grains and crops. This is capable of drying huge amounts of grains. This is wood drying. There are some Finnish companies that are interested in this technology, and we can dry up a wood plank of 50 millimeters wide in 8 days to its industrial thing. And basically, we don't need anything. There's a company that has been on the market for 20 years. It's gradually gaining momentum, and I'm happy that I have a part to play in it. And if you're interested, I can tell you how it all works. This is dynamics of growth of our company that's based on our institute. We've been growing since 2006, and we produce more than 1.5 tons of amorphous ribbon. And we pay all the taxes and we provide everything for ourselves. I would like to mention the people who were founders of Nano Program. And this is my chef, Viktor Fedorovich, Mr. Maslov, this is Mr. Uvarov, and of course Anatoly Shpak, and our current sponsor, the biggest sponsor, Anton and Boris. Thank you for your attention again. Thank you. You have convinced us on the stage of Ferro Ellis. The nanocompositor. I noticed 5 or 4 elements. Could you talk about this, for instance? From the very beginning. Right here. Ferrum, silicon, boron, niobium. What is the... Do you know the structure of X-ray this complex compound, and how can you provide the consistency? Okay, I had to skip this. I will just shortly tell you about it. So the chemical composition is basic. It so happened that in 1987 we saw it first. We started to see it, and at the same year the Japanese had patented it, a similar composition. It's a very simple composition. There's a borite, alpha solid alloy based on iron and silicon, and it creates one borite. Where does the copper and niobium disappear? The science never tells us. But the phases are not formed, whereas clusters are formed, and we have all the methods to control these processes. There was a department of Mr. Vinsky, and now the laboratory in my department deals with these issues. We can control these compounds even in liquid form. So we even monitor the structure of liquid compounds. But we have a certain reproducibility of these properties. It's not just a ribbon, but all the parameters and all the properties are controlled. There's a standard, and we know that there's a standard 15%. So the same 15% are a requisite to use in the magnetic materials. And if it's a special application, it's not 15. It's the deviation is 2%, not 15. Okay, let's push our discussion for the lunch break.